Hello, everyone, and thanks for coming to my talk. So I'm going to be talking about joint work with my advisor, Alan Mislov, and other colleagues from Northeastern, URECOM, MPI-SWS, UGA, and CNRS. Now I'm going to be talking about some serious privacy leaks in this talk. But before that, I want to start with providing some context about the advertising industry. Now, most of you may be aware that online advertising is rapidly dominating the $500 billion global advertising industry. But why is this the case? I'd like to argue that this is because online advertising is allowing increasingly fine-grained targeting of ads. To see why this might be useful for an advertiser, let's assume we are an advertiser for a theater and want to advertise an upcoming musical for teens. Now, ideally, we might want to show our ads to everyone out there, but this is going to cost a lot of money. So to get better value for money, perhaps we want to show it only to those people who are most likely to buy tickets, indicated here in blue. Some prime candidates might be people who have seen similar shows at a theater in the past. Now, in a world with only offline advertising, maybe you might place an ad on TV, thus paying to reach a lot of irrelevant people. But when online advertising came along, you could do better. For example, going to Google and placing an ad targeting particular search keywords such as music and theater. As these platforms, such as Facebook and Google, started to gather increasingly detailed data about users, they allowed us to do even better by letting us go and target users who have particular attributes. For example, teens interested in music and theater. So you can see that this increasing ability to target is very valuable to us as advertisers. So what might be the end game here? What if there was a feature which lets you target exactly those users you want to reach? Surprisingly, this feature already exists, and this is what we call PII-based targeting and study in this paper. Now here, PII refers to personally identifiable information, which is information such as emails, phone numbers, etc., which uniquely identify people. Now, how does this work? So the advertiser goes to the ad platform and uploads a list of PII corresponding to the people he wants to advertise to. The ad platform internally matches this and finds matching users and tells the advertiser some rough statistics, including how many people matched. This is to help the advertiser tailor his campaigns. Finally, the advertiser advertises to these matching users. Now, this feature has two advantages for advertisers. One is obvious, one less obvious. The obvious one is what I just told you about, which is that the advertiser pays only for those users he wants to reach. The less obvious one is that the advertiser can now exploit various external data sources, such as lists of past customers, public data such as voter records, and external data from third-party data brokers. Consequently, this is very popular and offered by all the major platforms, including Facebook, Google, Twitter, Instagram, and so on. It's called different things on these different platforms. On Facebook, it's called custom audiences. On Google, it's called customer match. And on Twitter, it's called tailored audiences. So this is clearly great for advertisers. But when we looked at this feature, we were very concerned. And I'll try to explain why. So what's going on here is that these ad platforms have gathered rich databases of private user data. And if you step back, what's happening with PII-based targeting is that advertiser links arbitrary sets of PII with these databases, effectively performing a join, and gets back some rough statistics, including how many records were successfully joined. But wait, if you step back, this is a query to the user database, leading us to naturally suspect whether these statistics could inadvertently leak some user information. And this is all the more serious because anybody can be an advertiser. For example, on Facebook, to be an advertiser, all you need is a Facebook account, and we all know how easy that is to create. So thus motivated, we study the security and privacy implications of Facebook's PII-based targeting. So we focus on Facebook's platform because it's the largest platform, most mature, and supports the most diverse kinds of PII. And we indeed discover attacks that allow an advertiser to learn the entire PII of users, to de-anonymize individual web visitors, and also de-anonymize web visitors en masse. Finally, we propose a novel defense for these attacks. But before I talk about these attacks, I need to first provide some background about how Facebook's PII-based targeting works. I'll then talk about two key findings that we found that enable these attacks. And then I'll walk you through one attack, one of the major attacks we found, which lets us infer the entire phone number of a victim. The others are in the paper. And finally, I'll talk about defenses and conclude. So to understand Facebook's PII-based targeting, let's assume we are an advertiser who's going to place an ad. So we go to the platform and first specify which PII fields we want to use. So you can choose from 15 different fields, such as email, phone number, name, date of birth, etc. You then upload a record, CSV file of user records that you want to target. Facebook internally matches this to Facebook users and provides the advertiser with this concept called an audience of matching Facebook users. So the idea here is that the advertiser should not know who is in this audience, but should be able to advertise to them. But later in this talk, we are going to see that the advertiser can actually find out who is in this audience. So moving forward, the advertiser can then combine these audiences and target users in any of 1 or 2 custom audiences. And finally, Facebook comes back and provides size estimates about how many people are in the audience. And this you can think of as the result of the database query. Now I must emphasize that all our attacks rely only on these size estimates, which are clearly fundamental to PII-based targeting. So we spent a lot of time reverse engineering how these size estimates are computed, and we found 2 key implementational features. Now you may all find this very reasonable. Indeed, if you had implemented this, you might have made the same choices, but we'll see that these lead to attacks. So the first finding is that size estimates are obfuscated by simple rounding. Now the details are in the paper, but basically we found that these size estimates are consistent across time, monotonically increasing, and all come from this set here. The second finding is that records matching the same user are deduplicated. To explain what this means, let's assume we upload a list of 4 different records to Facebook ad platform. Let's assume the first record matches some user, the second record matches some other Facebook user, the third record matches some other Facebook user, but that the fourth record matches the same user as the first one. Now Facebook is going to internally determine, yes, these are the same user, deduplicate them, and consider this as an audience of 3 users. Now this is perfectly reasonable because advertisers would have PII from different sources and want them deduplicated, but these reasonable implementation features lead to attacks. Before I talk about the attacks, I need to take you through 2 steps. So the first, let's assume that we have a list of phone numbers. Assume for now that these are US phone numbers. Secondly, assume we have the email address of a particular victim. Assume for now that the victim has a Facebook account and that this email address matches that Facebook account. Now the challenge here is to ask, given only the victim's email address, can we find out if this victim is in this list of phone numbers? So what we are going to do is play around with Facebook ad platform and see whether we can find this. But the first challenge in doing this is if you go and upload this to Facebook, it's going to give you a coarse-grained size estimate. Let's say you upload it and you get 670 back. This is not telling us much. But what if you started playing around with this by adding a lot of unrelated phone numbers, such as phone numbers from Italy? So let's say you add 1 phone number from Italy and you see that the size estimate is still 670. It's not telling us much. But you add 1 more, let's see the size estimate goes up to 680. Now that's telling us something. What does this mean? It means that this audience right here fell exactly on the rounding threshold, meaning adding even 1 more user to it causes the size estimate to go up from 670 to 680. So there you have it. You can circumvent rounding by finding a threshold audience and thus get some information from the ad platform. So now that we have this, let's add the victim's email address to this threshold audience. What are the possible answers here? You could either get 670 or 680. What would we expect to get? Remember, I assumed that the victim's email address matches a Facebook account. So what you would expect is 1 user gets added to that threshold audience and the size goes up to 680. But what if instead the size estimate remains at 670? What could this mean? It means the victim's account was not added to this audience, and that can only be because of deduplication, and that one of the phone numbers out there in that list matched the victim. So there you have it. So you know now that you're able to determine that the victim is in a list of phone numbers. If on the other hand you had seen 680, it means it's not. Now you might be thinking about that assumption. What if the victim's email address does not match a Facebook account? Using similar ideas, we can actually check whether that's the case and the details on the paper. So this is a cute attack. But how many of you are able to see how this can lead to something much more serious? Indeed, I'm now going to talk about how you can use this to learn the entire phone number of a victim. So we've just seen how we can ask whether a victim is in a target list of phone numbers. Now let's say we want to ask if the first digit of the victim's phone number is 1. What if you uploaded a list of all possible phone numbers starting with 1 and asked whether the victim is in this list? If yes, this means the victim's phone number starts with 1. If no, not. You can play this game and ask if the victim's phone number starts with 2. You can play the same game and ask whether the victim's second digit is 1. And thus, playing this game, you can learn the entire phone number of the victim, knowing only the email address. So this seems rather surreal, so let's test it out. So we tested this on friends and family from Boston and France. Now, phone numbers in the US look like this. You have the country code, 3 digits of area code, followed by 7 more digits. 617 is one area code for Boston, meaning we need to infer 7 more digits. Now, let's say for the first digit, we want to check whether it's 0, so we would set that to 0 and enumerate all possible values for the remaining 6 digits, meaning 1 million numbers. So we upload this list of 1 million numbers to Facebook. There are 10 possible values per digit, and there are 7 digits to infer. So we need 70 lists of 1 million numbers each. So we did this for 2 area codes in Boston, so 140 lists of 1 million numbers each, and we were able to upload this over the course of a day. Similarly, for France, we uploaded 82 lists of 20 million numbers each, and this took us a week to do. Now, you might be thinking of 2 things here. You might be thinking, look, these are very conspicuous uploads, but we talked about in the paper how you can make it much more covert. The second thing you might be thinking is these are very time consuming, but this is actually a one-time step. Once you have this list ready, you can reuse them across all victims. So now that we have them, let's check whether it works. So we were able to successfully infer 11 out of 14 numbers of volunteers from Boston and all 8 from France. Now we looked at these 3 remaining cases in Boston and found these were people who had provided multiple phone numbers to Facebook. So in our paper, we talk about an extension to our attack where you can learn all the phone numbers of even these 3 people. Now our attack took around 20 minutes per victim, showing it's already pretty effective. But in the paper, we talk about how you can speed it up even further. So now I've spoken about one of the serious attacks that we found. Before I talk about defenses, I want to briefly talk about the other 2 major ones we found. So both of these other 2 help you de-anonymize website visitors, and these are possible because all ad platforms, including Facebook's, has this feature where advertisers can target people who visited their website. So the way this works is the advertiser goes to his website, places a tracking pixel provided by Facebook. Facebook internally tracks these website visitors using cookies and finds an audience of website visitors. Now to the advertiser does not know who these website visitors are. These are anonymous. Facebook knows them because it's able to match them using cookies to its identities. So these identities which are anonymous, but we can find that who these actually are by using similar ideas. So we can ask whether the victim is in this audience of website visitors, thus de-anonymizing a particular victim. You can move further and learn all the website visitors' phone numbers en masse, thus de-anonymizing all of them. So finally, all these attacks I've talked about are easy to launch and have large-scale impact. Anybody can conduct the attack. Any Facebook user can be a potential victim. No ads are placed, so no money is spent, and there's no interaction with the victim, meaning that the victim can never find out that he was attacked. And finally, these only rely on size estimates, which are clearly fundamental to PII-based targeting. So now that we have these serious attacks, we are hoping there might be a good defense for these attacks. Turns out it's a very challenging problem. Now defenses could either focus on the main feature that we use, size estimates, looking at one of the 2 implementation features, obfuscation or deduplication. Defenses could also focus on raising the barrier to attacker. Now we looked at a bunch of defenses dealing with size of estimate obfuscation and the barrier to attacker, and found they were all non-fixes, showing how challenging the problem is. And these were non-fixes because they did not trade off well between the privacy of users and utility provided to advertisers. So if you look at size estimate obfuscation, you could either have no size estimates, or you could have coarse-grained size estimates such as rounding. You could add noise to size estimates. Or to raise the barrier to attacker, you could require an approval process for advertisers, have some financial disincentives, rate limit queries, have some sort of anomaly detection. But we talk about in the paper how all these defenses can be circumvented or lead to a very high loss in utility. So instead, we focus on deduplication and propose that we don't deduplicate distinct pieces of PII matching the same user. So to understand what this means, remember our example from previously the talk, where you have 4 records, where there's an email at the top and a phone number at the bottom matching the same Facebook user. We say do not deduplicate these 2, consider them as 2 separate, and consider the audience as having 4 users. Now, this can be tricky to implement because records can have multiple types of PII. So you can have all sorts of combinations, such as user wants email address, the same user's phone number, user wants email address, some other user's phone number, user wants email address, and some invalid phone number. And these have to be carefully handled. We talk about how in the paper. Now, we prove that this is robust, but it's not a perfect solution because it can still lead to inflated size estimates or loss in utility for some advertisers who might have a lot of PII from different sources corresponding to the same user. Now, we responsibly disclosed this to Facebook and communicated our proposal. Facebook responded by deploying a stricter fix, saying that there's not going to be any size estimates for audiences created using more than one type of PII. So we're thankful for Facebook to deploy that fix. So finally, to conclude, we've seen that this trend towards targeting has led to PII-based targeting. And we've seen that PII-based targeting allows queries to the private user databases of ad platforms. In this talk, we have shown fundamental flaws in PII-based targeting which lead to serious PII leaks. Now, we have only looked at one kind of statistic that Facebook provides. It provides many more. And there are so many other platforms out there. And these platforms are all only growing more rich over time, pointing to the need to audit these advertising platforms for privacy leaks. Thank you, and I'm happy to take questions.